Okay, in this video I got a variety of problems here. My question number 5 is find a general antiderivative. We will not need U-substitution for that one. 6 is a definite integral I'm going to evaluate using the fundamental theorem of calculus, and I think I might need, that looks like a tricky integral, I might need a U-substitution there, we'll see. For question number 7 here, find the derivative of this crazy looking function. Well, we're going to use again the fundamental theorem of calculus, a different part of it. There's usually, we call them part 1 and part 2. So this one actually is a lot easier than it looks if we understand that concept. And then in my 4th question, or what I'm calling question 8, I want to find that area right there. Okay, let's do it. For the first one, we like to do some algebra sometimes before we do calculus. If I can understand that if I divide x squared into all these, it's going to be a much easier problem. That is 5x cubed over x squared is 5x, minus 7x over x squared is 7 over x, and plus, and this would just be 3 over x squared. I'm going to choose to write that as 3x to the negative 2. So I'm going to use my general power rule integration for that one and that one. That means I'm going to add 1 to the exponent, divide by that new exponent. And then this is the one case where I won't do that. All right, that you should recognize that as a log, the derivative of a log, natural log function. So I got 5x squared over 2 minus just this guy is, if you want, it's 7 times 1 over x dx, which is going to be 7 times the natural log of x, right? That's the one where we don't add 1 to the exponent here. So that's 7 natural log x plus, and I'm going to do the add 1, divide by the new power, so plus 3x. If you add 1, you get a negative 1, then divide by that new power plus c. So that's my answer. The only thing I would change is this term, right? I don't want to divide by negative 1. Plus 3 divided by negative 1, of course, would be just negative 3. So let's make that look a little nicer, and that should just say minus 3. Okay, so this guy, I'd have to maybe do a little trial and error to see what, I don't know what the antiderivative of sine squared times cosine is, right? So I'd have to do a little bit of trial and error with u. Basically, you have 2 choices for your u for u substitution. It's either sine or cosine, right? And then I go through my process to cancel out dx and see what happens. But typically, we would let u be the input of my composite function, right? The input of my composite function. So if I rewrite sine squared like that, it's a little bit easier to see. So my first guess is that u would be sine x, right? It's being squared. There's an operation on that function. So then I would rewrite, I just go through my u sub process, the derivative of sine, and then solve for dx. Okay, and now be careful. This is a u substitution definite integral, so I gotta sub those guys out. When x equals 0, u equals the sine of 0, so that would be the same. When x equals the upper bound pi over 2, u equals the sine of pi over 2. So what's the sine of pi over 2? That is 1. So now I can complete my substitution. Instead of going from 0 to pi over 2, I'm going from 0 to 1. U squared times the cosine x is still in there, and then dx I solve for is du over cosine x. So I chose the right thing for u based on what we typically do, right? I mean, the other option would have been to maybe guess u equals cosine x and see if that worked out. But typically we let u be the input of our composite function, which in this case was sine x. Okay, so now I'm looking at a real easy problem. I integrate u squared du, so that's u cubed over 3, and I don't have to worry about 0 and pi over 2 anymore, at least the original bounds, the original 0, because I already took care of that when I did this, right? So now I took everything to U, so all I have to do is plug stuff into U. So my answer would be 1 cubed over 3 minus 0 cubed over 3, which is a little bit of overkill. My answer should just be a third. Okay, if I want to take the derivative of this next function, I'm using what I called part 1 of the fundamental theorem of calculus. So this looks like a really complicated problem, but it's not. The derivative of f of x is the derivative of this thing. And you can think about it as taking the antiderivative and then the derivative, so they cancel each other out, but we'll just have a new variable in there. So my answer is simply x times 1 plus 5x squared. Without actually having to antidifferentiate or differentiate, you're using that idea that you're taking the derivative of an antiderivative, so it's sort of like an inverse operation, and you're just back where you started. X times the square root of x plus 5x squared. X plus 5x squared. Okay, a basic application of integrals or the fundamental theorem of calculus, or really how we kind of introduced this topic was with an area. So if I want to find this shaded region area going from 1 to E, so I'm going from, so the area is equal from 1 to E, and this function right here is given as 5 over 2x dx. So that's how I set it up, and I might factor out, I like to factor out my constant, so I factor out the 5 halves, and then I'm just left with 1 over x. I'm going from 1 to E, and this will just be the natural log of x. So it's just 5 halves times the natural log of, I don't need my absolute value bars because these are both positive, and I evaluate that from 1 to E, and then I will be done. So that area is exactly the natural log of E minus the natural log of 1 times 5 halves. Natural log of 1 we know to be 0. The natural log of E we know to be 1. So I get the exact area of 5 halves.